have discussed what is meant by a product term, right? So product term is nothing but adding the two literals, two or more literals, that is called as product term. Now we will try to understand what is meant by a sum term. It is defined as sum of, very important, the sum of literals or group of literals that are added together. Okay, so in the previous definition what we have written there, so the group of literals that are added together, added means multiplying, odd means summing, okay, odd together. So if you just see the examples, so A is also one of the literal, okay, A is also one of the literal, so A is a literal and that I can call it as a sum term. Then A plus B is also one such example, and A plus B, A bar plus B, this is also one more example. If you just observe between the literals there is one sum. Okay, now how I can write this? How I can write this A by making use of a sum term. Okay, let me write it as OR gate. So A, and let me write it as A. Sorry, let me write it as 1 here. So what you will get here obviously? Obviously you will get it as 1 only. How? Because OR gate is nothing but if any one of the input is 1, my output is 1. So if I am writing here as 0, then you will be getting here as what? You will be getting it as A only. Okay? A, whatever I am sending, A can take either 1 or 0. If I am giving 1 here, 1 will come. If I am giving 0, 0 will come. So therefore I can write it as by making use of OR gate. So that's why I can represent this expression by making use of a sum term also, that is by making use of OR gate also. Now come back to this example. Okay, and how to write this? How to write the pin numbers for this? So whatever we have discussed for the AND gate IC configuration, the same configuration holds good. That IC number is 7432. That was 7408. AND gate to IC number was 7408, and the OR gate to IC number is 7432. So how many OR gates are available? Totally 1, 2, 3, 4. 4 gates are available, and again 7 is always connected to ground and 14 is always connected to VCC. 1 and 2 are acting as an input for the first OR gate and 3 is acting as an output for the first OR gate. Similarly, if you just observe the figure, then you will get to know which all the pins are acting as inputs and which all the pins are acting as output. Now, let me assume that I am using the first OR gate in this IC. If I am using the first OR gate, what are the input numbers? That is nothing but 1 and 2. Right? That is 1 and 2. So what is the output? What is the output of the first OR gate? It is 3. So therefore I am writing it as 1, 2, 3. Okay. Next, coming to this example, what are the two inputs are there? It is A and it is B. The output is nothing but A plus B. Right? A plus B. For example, I am using the second OR gate now. For example, if I am using the second OR gate, what is the inputs? 4, okay, 4 and 5 are the inputs. 6 is nothing but the output. Okay. Next example is A bar plus B. So if you want to get A bar, I have to go for the NOT gate, right? I have to use the NOT gate. Okay. So now I will be using the NOT gate here. So therefore I will be getting A and A bar here. Okay. And B I am directly passing. So these two inputs I have to give it for OR gate. Okay. Now if I want to write the pin numbers, I have to write the pin numbers for NOT gate also. That's why I have written the configuration, IC configuration for NOT gate, and all these things you have already copied in your book. Okay, in order to explain how to write the pin numbers, I have written once again. Okay, so 14 pins are there in the 7404. The IC number for the NOT gate is 7404, and if you just observe here, there are 6 NOT gates. How many NOT gates are there? There are totally 6 NOT gates. So this 6 NOT gates, among the 6 NOT gates, which NOT gate I have to use in order to implement here? I can use this or this or this. Any NOT gate you can use. Okay. So right now, in order to understand or in order to explain the concept, I am assuming it as the first NOT gate. So if I am assuming the first NOT gate, what are the pin numbers? So 1 is the input and 2 is the output. 1 is the input and 2 is the output. So this 1 is the input and 2 is the output of what gate? 1 and 2 are the input and output of NOT gate. Okay, next. So now again I have to write the pin numbers for OR gate. Now I am using, let me assume that I am using this third OR gate. If I am using the third OR gate, what are the pin numbers? It is 12 and 13. So 12, let me write this 2 here, and 12, okay, and 13. 12 and 13 are the inputs of the OR gate. Okay, 12 and 13 are the inputs of OR gate. And what is the output of the third OR gate? It is 11. Okay, this much you understand. I will tell later on how to differentiate these numbers. Okay, you should not assume that 12 and 13 are the numbers of the NOT gate. I will just tell you how to differentiate all such things. But right now, 1 and 2 are the input and output of the NOT gate, and 12 and 13 are the input of the third OR gate, and 11 is the output of third OR gate. So this is how you need to write down the numbers. If you write the numbers, then only you will be able to connect it with the lab. Okay. So what are the things we have discussed today? So what is a logic gate? What is a combinational circuit? Then what else we have discussed? We have also discussed what is meant by a literal. Okay, what is meant by literal, and what is a sum term, and what is a product term, and the pin configuration of AND gate, OR gate, and also the NOT gate. And also you have very briefly understood how to write the pin numbers for all these gates, right? So if you just remember these things, okay, if you just remember the pin configuration of AND or NOT, then you can easily write down the pin numbers. Okay. Now I would like to write the truth table for AND gate. So what is the truth table for AND gate? I have to write it as A into B. This is output of AND gate. Okay. So since I am considering the two inputs, so how many combinations I should have? So 2 to the power of 2. Since I am considering the two variables, you will be having the 4 combinations. Okay, 2 square is nothing but 4 combinations: 0, 0, 0, 1, 1, 0, and 1, 1. So this is nothing but 0, this is nothing but 1, this is 2, this is 3. So this is the decimal equivalent of this binary representation I have written here. No need to write this, only to understand I have written. So what is the AND gate means? If any one of the input is 0, means the output is 0. Since both the inputs are 0, I write it as 0. Here also 0. Here one of the input is 0, so therefore it is 0. 1 into 1. Okay. Here, since both the inputs are 1, okay, write it as 1. Okay. So this is the truth table for AND gate. Okay. Now I would like to write the truth table for OR gate as well. So A plus B. So what is OR gate? OR gate is nothing but if any one of the input is 1, my output is, if any one of the input is 1 or high, my output is high. So here both the inputs are low, so therefore my output is 0. Here if any one of the input is high, means the output is high now. Since one of the input is high, so therefore 1. One input is high, therefore 1. Both the inputs are high, therefore it is 1. Okay. One more important or easy method is 0 plus 1, 1, 1 plus 0, 1, 1 plus 1 also 1. Okay, should not write it as 2, it is 1. Just understand it is a OR operation. If any one of the input is 1, means the output is 1. Okay, next. I would like to write the output for NOT gate. So since there are only one input here, 2 to the power of 1, therefore it is 2 combinations. 0 and 1. So if I am giving the input as 0 to the NOT gate, my output will be 1. If I am giving the input as 1 to the inverter of the NOT gate, my output will be 0. It is just the complementary form. I hope you have understood the basic gates and the pin configuration and how to write the pin numbers. Very, very important. Till now, if you have any doubts, you can just message in the chat box. Okay. Copy down all these things.